Okay, um, I'm going to repeat the review that I gave in class on Wednesday. I'm doing this for a couple of reasons. One, you might have missed class, and you might like to see it. Two, the end was a little rushed, and you might like to see those questions again. Or you just may want to review this for further clarification. In any case, you're in complete control here. You can not watch it at all. You can pause it at any point. You can stop and come back at another time. Um, Use it as you see fit. So here's the first question. It asks us to evaluate and simplify um, these three expressions for the function f of x equals x times the quantity x plus 40. Well, f of x plus h means that wherever there's an x in the function, we're going to place an x plus h. And here, I place x plus h in a set of parentheses because it is this entire expression that's being substituted for x. Here I don't need a separate set of parentheses because they're already inside parentheses, and all of the operations inside those parentheses are addition. Well, now to simplify this, I expand by multiplying each term in the first expression by each term in the second. So that's x times x is x squared, x times h is xh, and x times 40 is 40x. The second term is h. I multiply that times x for another xh, and then I multiply it times h. That gives me h squared, and I multiply it times 40 to give me 40h. There are only two like terms, and that's the xh here and the xh here, so I have two of them. Put them together and I have 2xh, and that is as simple as we can get that expression. In part B, we are asked to subtract f of x from that expression, and to do that I have expanded the function by multiplying x times each term inside here. So I have x squared plus 40x, which is another way of expressing the function. It's the same thing, and you see that note here. Then I distribute the negative sign through each term inside these parentheses to subtract this function from this expression, and so that gives me a negative x squared and a negative 40x, and we have a positive 40x here, and so those two terms cancel additively, and we have a positive x squared here, and so those two terms cancel additively, and so the simplified expression is 2xh plus 40h plus h squared. In part C, we are to place this expression, the f of x plus h minus f of x, in the numerator and divide by h. So here it is, 2x plus h plus 40h plus h squared is the numerator. We have an h in the denominator, and in this next step I've factored an h out of each of these terms, and the h in the numerator and the h in the denominator then cancel, so our final simplified expression is 2x plus 40 plus h. And some of you have asked, well, can't I just in my head cancel out the h's and just knock this one off, knock that one off, and reduce the degree of this one by 1? And the answer is yeah, sure, as long as you don't make any mistakes doing that. I like to do it like this, simply to help me keep track of everything and hopefully prevent errors. It forces me to slow down, and slowing down, especially when you're taking a test, is often a good thing. Okay, now in question 2, we're given a price-demand function. So this is price as a function of quantity demanded. And we're going to use that to determine the revenue function, and then complete a table of values for various various sales or production levels. Excuse me. And so revenue is equal to quantity times price. Our quantity is X. That's how many items are demanded, produced, or sold. And our price, as given up here, is 2,000 minus 60X. And so I distribute the X times each term here, and that gives me 2,000X minus 60X squared. I then substitute each of these values into X in this function, and that gives me, the first value is given, 1,940, and when I substitute 5, that gives me $8,500. When I substitute 10, that gives me 14,000, and so on through the rest of the table. We've done this question a couple of times in class, separate from this practice exam. So that's all that's required of this question. Now we move on to question 3, which uses our answer from question 2. And so using that revenue and the cost function 4,000 plus 250x, we're asked to determine the profit function. Well, profit is revenue minus cost. Revenue is whatever you take in, and cost is whatever you spend in your production and sales of whatever item you're making and selling. And so my revenue function is negative 60x squared plus 2000x, and I've written it in this order in descending order because that's more common in mathematics. And then I subtract the cost function here, and I remember to put parentheses around the entire function. This entire function is inside parentheses because I'm subtracting the whole thing. If you don't do that, that is going to ruin any chances of getting the question right. So I distribute the minus through both of these terms, and that gives me a minus 4,000 and a minus 250x. When I subtract 250x from 2000x, that gives me my profit function, negative 60x squared plus 1750x minus 4,000. Now to find our break-even points, which is the next thing that's requested here, we need to find those quantities which give us a profit of 0. Breaking even means you are neither making nor losing money, so your profit is 0. So I set my profit function equal to 0, and then I factor. You can use the quadratic formula if you want, but the problem is set up so that it shouldn't be too difficult to factor. And the first thing you do when you factor is factor out the greatest common factor. Well, the greatest common factor that I can pull out of here is negative 10, and I think the fact that I bring the negative out is going to help with this factorization, with factorizing this polynomial, with factoring that polynomial. And here I have shown that the two binomial factors, absent the negative 10, the two binomial factors are going to be 3x plus or minus some number and 2x plus or minus some number. This exact hint is given on your test. So I don't know if you want to use the AC method or this guess and check method that I discussed in class, but I will tell you on the test what these two terms are going to be. So on the test, as a hint, this line right here, or at least this partial factorization will be provided in the question. So given that, my two terms are here are negative 80 and negative 5. Now, since negative 10 is not going to affect whatever the solutions are here, I set 3x minus 80 equals 0 and the 2x minus 5 equals 0 and solve from there. And my two break-even points then are 26.67 and 2.5. Now, it also asks for the intervals of profit and loss, and that's going to be from 0 to 2.5 will be an interval of loss. Above 26.67 will be, from 26.767 to infinity will be an interval over which we will lose money. And from 2.5 to 26.67, there will be profit. I didn't write those answers out here, but if you have any questions about that, you can email me or text me or call me. The number is 464-5781. Now, the last question that I'll cover in this part of the review is the average annual cost for a copier. And average cost is given by the cost function divided by the number of units, or in this case, number of years. So I place that function 2400 plus 100n plus 20n squared in the numerator, and n in the denominator, and simplify. Simplify this function by breaking it into three separate fractions. And 2400 over n can't be simplified any farther, so that one is as good as it gets. 100 over n, though, simplifies as 100 because the n's cancel, and 20n squared simplifies as 20n because one of these n's cancels with this n here. Now, the graph will be provided on the test, as it is here, and so you'll use that graph to choose your the points that you'd like to test to see where the minimum lies. And if you look at the graph, you'll see that it seems to bottom out right about here, from 10 to 12, somewhere in that region. So we substitute 10 into this average cost function, and so that's, instead of x, we have 10 here and 10 here. And that simplifies as 540. And we do the same for 11. N equals 11. And that simplifies to $538.18. And then at 12, that simplifies to 540 again. So it looks like we go from 540 down to 538, back up to 540. And so it appears that n equals 11 is the age at which average cost is a minimum. And if that is the case, then average cost is a minimum at $538.18 at an age of 11 years. And I'm going to stop this review right now and pick up with question 5 on part 2.